a real number such that mod x is less than 1, which of the following is statement is false? You can see option A, if x belongs to q, then summation x raised to the power m belongs to q. And option B is if summation x raised to the power m, then x belongs to q. It means this is option A and B are if and only if result. Means x belongs to q if and only if summation x raised to the power m belongs to q when m is greater than equal to 0. So we have to check these two options A and B. Now option C is saying if x is not from Q, then summation m x raised to the power m minus 1 doesn't belong to Q. And option D is saying summation x raised to the power m upon m converges in R. So first we are solving or trying to solve option A and B. What is these options saying? Suppose summation x raised to the power m can be expanded as x raised to the power 0 because of m is greater than equal to 0, x raised to the power 0 plus x raised to the power 1 plus and so on up to x raised to the power m. This is nothing but this is 1 plus x square and so on. Now you can easily observe it seems as a geometric series with common ratio x, and condition on x is mod x is less than 1. So this is geometric series and we can find sum of geometric series with the help of a upon 1 minus r, where a is the first term and r is common ratio. And this is true when mod r is less than 1. So using this fact, we can easily find the sum of this series. So this one is equal to 1 upon 1 minus x, and if x is belong to q, then this implies 1 upon 1 minus x belongs to q, and if this belongs to q, then x is coming from rational number. If x is irrational number, then difference or difference or operating with a irrational number again is irrational number. So if x belongs to q, then this one is true, and if this one is true, then x belongs to q. So option A and B are true, but we are seeking false statement, so A and B are not desired option. Now come to C and D. Going to see, first we are trying to solving option D because of it seems as easy, because of we have to check convergence of the series. So series is summation x raised to the power m, summation x raised to the power m upon m, and condition on m is greater than equal to 1. So you can write am is nothing but x raised to the power m upon m. So using ratio test, we have to find limit x tends to infinity mod of an upon or am upon am plus 1. We need to take because of we are checking absolute convergence of the series. If series is absolute convergence, then it will be convergent. So we need to take a mod of this one. If mod of this expression we are not taking, then you may mislead, because of if expression we are obtaining 1 upon x and x is mod x is less than 1, then 1 upon x will fail when x is negative. Means convergence of the limit sorry convergence of the series is when limit L is greater than equal to 1, and this limit is less than 1 when x is coming from minus 1, x is lying between minus 1 and 0. So you will check this concept later. First we evaluate this limit. So this is limit x tends to infinity, and mod of this one will equal to x raised to the power m upon m divided by x raised to the power m plus 1 upon m plus 1. So this is nothing but limit of this expression will equal to 1 upon mod x when x tends to infinity, and mod x is less than 1. It means reciprocal of this one will be 1 upon mod x greater than 1. So because of limit is greater than 1, so using D'Alembert ratio test, implying this series is convergent, so option B is again true. Option A, B and D are true. It means option C will be false, and this will be the desired option. So key is option C.